Now you see this machine right here is a 1958 Lincoln transition model. I'm going to show you something here that's all theory. That there's might be some welding in this video, I don't know yet, but this is all theory, and this is going to save you on a job here. This is going to save you. This is going to save you from getting weld faults. This you're not going to get porosity. You're not going to get you're not going to be slow. You're not going to get burned through. You're not going to blow a hole in the pipe. You don't have to over grind or nothing. You're going to be able to stack. You're going to know how to set your machine after this welding video here. Every time I say second gear 70, you see, think back to what I'm showing you right here. This is second gear 70. This side is the amperage range. This side is the voltage range. This is second gear 70. This is third gear 40. Now, anytime I say low gear 70, this is what I'm talking about. This is low gear 70. And this is high gear 40, okay? This is a high amperage range, and this is a low voltage range. The difference between high gear 40 and low gear 70, the amperage is the exact same between the two. The difference is the voltage. This is the voltage. The voltage is also the RPMs of the engine. The RPMs of the engine and the voltage are hand in hand. Now I'm going to be talking about second gear 70, third gear 40. I'm going to be talking about if you're burning, say, a 1/8 7018 electrode. The smart thing to do would be put up to fourth gear if you want to see if you want to stack metal or whatever, deposit a lot of metal in a very short amount of time and drop the voltage so the puddle solidifies. You'll be in fourth gear, 20 and 10. If you're burning 532, you'll be in fifth gear, 10, 20, 30. It depends on the machine. The 1969 Lincoln Redface behind me, I can burn at fifth gear and drop the voltage all the way to 10, doing position weld. I'm able to deposit a lot of metal in a very short amount of time due to the volt amp curve, due to using arc length manipulation, due to the fact that I'm more amp heavy than volt heavy, so I'm able to hold a very tight arc and push on the electrode. I will not snuff out. Burn off rate increases because I'm holding a tight arc. As amperage increases, voltage drops off. So I'm able to deposit a lot of metal in a very short amount of time. When I'm weaving vertical up, hold a tight arc in the sides, deposit a lot of metal. Burn off rate increases due to the lack of voltage. You see I'm running very low voltage due to the lack of voltage. Due to the volt amp curve using arc length manipulation, the voltage drops even more when I'm holding a tight arc in the side bevels. Due to the lack of voltage, the puddle will solidify very quickly. I'm able to stack a lot of metal in a very short amount of time, knowing how to set the machine. Now when I say that guys run at, you look at some guys' remotes and their voltage is 70, 80, 90, 100, maybe third gear, 80, 90, 100, fourth gear, 80, 90, 100, and they're welding 7018, doing a vertical up weld. Say if they're your tag partner on, say, a heavy wall pipe, those guys are going to be screwed. The reason why they're going to be screwed is because they have a lot of voltage in the arc and lesser amperage. With having more voltage in the arc and less amperage, the puddle is very soft. They have to add arc length. They have to have a gap in between the tip of the electrode and the puddle, because if the electrode touches the puddle, it'll stick and it'll snuff out the arc. So these guys, because they have more voltage in the puddle and the puddle is very soft, they have to give arc length just so they do not touch the pipe and snuff out. When they give arc length, that that the arc length manipulation comes into effect. Giving arc length so you don't snuff out because you're running too low of amperage and too high of voltage. Since you have such a soft puddle and you have to incorporate arc length, you have to give arc length a normal arc so you don't touch the pipe and snuff out. With the increase in voltage, since you're already running a higher voltage setting in the first place, adding more arc length increases the voltage even more, which makes the puddle even softer. Anytime you accidentally touch the pipe, the electrode will snuff out. Sometimes it'll reignite and the welder will keep welding. Every time it reignites, it leaves porosity. It leaves porosity because the electrode snuffs out. It reignites again, and the tip of the electrode is bare metal, so it'll leave surface porosity. That's where you get your porosity from. With the increase in voltage, your puddle is very liquid. Your puddle takes a longer time to solidify. If you're trying to do a vertical upweave, you cannot stack because you move from the left hand side over to the right hand side. Your left hand side is still relatively liquid because you have a lot of voltage in the puddle. You move from the left hand side over to the right hand side. You move from the right hand side over to the left hand side. The heat collects in the middle of the weld. The opposing side you just left is not able to fully solidify because there's a lot of voltage in the puddle. The heat collects in the middle. You're more likely to burn a big hole in the middle of your root pass because there's a lot of voltage in the puddle. With a lot of voltage in the puddle is more liquid. It takes longer to solidify. If you're stacking metal, say vertical up, 7018, heavy wall pipe, you'll be in 4th gear, 10 and 20 volts. That's with 1/8 electrode, 532 electrode, 5th gear, 10 and 20 volts. With the reduction of voltage, you're at the left hand side. You can hold a tight arc into the side of the pipe there. Amperage increases, burn off rate increases, voltage drops off. Puddle solidifies because of lack of voltage, burn off rate increases. Deposits a lot of metal in a very short amount of time. Move from the left hand side over to the right hand side. The second hold a tight arc, amperage increases, burn off rate increases, voltage drops off. The left hand side of the puddle solidifies. There is not a concentration of heat in the middle of the puddle there because the puddle, from when you move from the left hand side over to the right hand side, the left hand side is starting to solidify and the whole puddle is carrying over to the right hand side. You move from the right hand side over to the left hand side. The right hand side starts to solidify. The heat is not collecting in the middle. The right hand side, the opposing side you just left, will not remain relatively liquid because you're running high amperage, low voltage. You're less likely to burn a big hole in the middle of the root pass. You're less likely to burn through because your puddle is solidifying. It is not concentrating the heat in the middle of the puddle, and the opposing side you just left is not remaining a liquid. When it comes to stacking, the opposing side you just left has become solidified because there's less voltage in the puddle. 4th gear, 5th gear, high amperage. Low voltage setting, 10, 20, low voltage setting. Able to burn 1/8, 718, 532, 718, position weld, vertical up. For stacking, you move from the opposing side, you move from the left hand side over to the right hand side. The opposing side solidifies. You're able to take your liquid puddle and stack it on top of solidified metal. When you're at 2nd gear and 80, 90, 100, 3rd gear and 80, 90, 100, move from the left hand side over to the right hand side. Move from the right hand side back over to the left hand side. You cannot stack metal on top of metal that has not solidified yet. The opposing side you just left will remain still relatively either A, or liquid, or B, has not come down in temperature yet for it to solidify fully, for it to accept a liquid puddle on top of a solidified metal, because you have too much voltage in the puddle. When you have too much voltage and too little of amperage, the puddle remains liquid. It takes longer to solidify. You cannot stack on top of liquid metal The heat collects in the middle of the weld because the opposing side you just left has not solidified. You have a lot of trouble shaping the weld because it's very liquid, takes longer to solidify. More likely to create porosity because the arc is very soft with increase in voltage and the decrease in amperage. The puddle is very soft. You have to add arc length. You have to give arc length so the tip of the electrode does not touch the pipe. Because you're running high amperage and low voltage. Sorry. Because you're running. Let me get this right here. Because you're running low amperage and high voltage. You have a lot of voltage in the puddle. You have a lot of voltage in the puddle. That is your setting. Your setting is a high voltage setting. You cannot hold a tight arc to the pipe because once you touch the tip of the electrode to the pipe, you'll snuff out. Therefore, because you're running high voltage setting, you have to give arc length to the pipe so you do not touch the pipe and snuff out. When you give arc length, and there's a gap in between the tip of your electrode and your puddle, arc length creates normal arc, decreases amperage, and it increases voltage. So you have an increase in voltage using arc length, and you have an already volt heavy setting on your machine, so you're counterproductive. The very second you do touch the pipe, you'll snuff out. The arc will reignite. Bare tip of the metal, bare tip of the electrode will be shiny, bare metal. You'll throw in porosity there and you'll keep welding because the electrode reignites. That's why you get porosity. So when I refer to low amperage and high voltage, I'm referring to second gear 70, third gear 70, fourth gear 70. When I talk about high amperage, low voltage, I'm talking about second gear 40, third gear 40, fourth gear 40, fifth gear 40. The amperage is exact same in between the two. The amperage is the exact same. The difference is the voltage. These are two different remotes. The remote on the left hand side is for an inverter welding machine. This is for a Lincoln Ranger 305G. Also for a Vantage and other inverter welding machines. The remote on the right here is for a generator welding machine. This specific remote is for many of my SA200s, generator welding machines. The difference between the two, you see arc force on an inverter. Arc force is your voltage. You have your soft setting and you have your crisp setting. When it's soft setting, that's high voltage. When it's crisp setting, that's low voltage. You see, when you change the current on the remote here for an inverter, you're changing the amperage. The voltage remains. You do not change the voltage on an inverter because the voltage setting is your arc force. I believe they do make remotes where you can change the voltage, which happens to be your arc force. However, on an inverter, you are changing the amperage, and the puddle characteristics, which is your voltage, does not change. And your puddle characteristics, your voltage on an inverter is the arc force. A soft setting is high voltage, and a crisp setting is low voltage. This is a generator welding machine here. This is the remote for a generator, such as my SA200, an SA250, 300, 300D, Classic 1, Classic 2, Classic 3, etc., etc. On a generator welding machine, you change the voltage. You also change the RPMs of the machine. You change the puddle characteristics of the machine. This is a low voltage setting. This is a high voltage setting. This, if you read a textbook, this is narrow bead, high crown, quick to solidify puddle, lacks voltage, metal solidifies, so you're able to stack metal on top of a liquid puddle on top of solidified metal. As you go up, the puddle starts to become more liquid, washes out better, becomes flatter, more voltage. Flows out better, longer to solidify, also becomes softer, lacks dig characteristics, lacks penetration characteristics. Your puddle, the machine lacks the drive and the oomph if you're at a low amperage and high voltage setting. If you're doing, say, a fill pass on downhill pipe, your slag will run in front of you if you're on low amperage, high voltage setting. Your machine will not be able to push back the slag. The slag will run into your puddle. If you go up a gear into a higher amperage range and you drop the voltage, your machine will be able to push back the slag. You'll be able to burn out to wagon tracks because you, at a higher amperage and low voltage setting, you'll be able to burn out wagon tracks because now you have the dig characteristics. Your machine is not soft like it is at low amperage and high voltage. At high amperage, low voltage, say like 4th gear 10, 4th gear 20, 5th gear 10, 5th gear 20, you're going to be able to stack metal. Because with a reduction in voltage, you're able to, the opposing side you just left has solidified. Or if you're welding downhill, your ripple solidifies quickly. I'll now talk about volt-amp curves here. Now, as you can see here, this is a volt-amp curve. This is 3rd gear and 40. Study the volt-amp curve. This is high amperage and low voltage setting. 3rd gear 40 is the exact same amperage as 2nd gear 70. The amperage is the exact same, the voltage between the two is different. Now we go to a high amperage and low voltage setting. So we're at 3rd gear 40. We're the high amperage range. You see this one go up to 225. It's probably more like 4th gear, but whatever. Don't worry if it says 3rd gear or 4th gear, it doesn't matter. All you need to know is high gear, low voltage, low gear, high voltage. The reason why I'm using 40 and 70 is because those are the numbers that the amperage is the exact same within maybe 5 or 10 volts. But for the most part, the amperage between the two gears, 2nd gear 70 and 3rd gear 40, or 3rd gear 70 and 4th gear 40, the amperage is the same, the voltage is different. Now we're at high amperage, low voltage. We're at high amperage, 225 amps. We're at low voltage. Voltage is 50. This is a volt-amp curve. Over here, this is 2nd gear, 70 volts. We're at a low amperage range and a high voltage. The low amperage range, we only go up to 150 amps. Well, we have a lot of voltage. The voltage is all the way up to 70. Now, we see here, this is arc length manipulation. On a drooping volt-amp curve, a generator welding machine such as an SA200, SA250, 300D, etc. Those machines have a drooping volt-amp curve. When you use arc length manipulation, a tight arc increases the amperage and decreases the voltage. So it's a trade-off. It's an increase in amperage and a decrease in voltage using a tight arc. When we hold a normal arc or give arc length, the amperage drops off, but the voltage increases. If you notice how drastic the change is, this may be only third gear 40. You can imagine, say, fourth gear 40 or fifth gear 40, or even fourth gear 10 or fifth gear 10. You can imagine how low the voltage will be and the amperage, you see? Suddenly, you use arc length manipulation, you hold a tight arc in the side bevel there. Your amperage increases, your burn-off rate increases, your voltage drops off. You may go up a huge significant amount of amperage. You give arc length across the middle to add voltage into the puddle, and your voltage may drop off your amperage may drop off quite significantly, and your voltage will increase. That is high amperage, low voltage. We look over here, and a lot of welders, when you look at your tag partner who is welding on the other side of a pipe of, say, like a heavy wall, vertical up position weld, if you look at his remote and it says 80, 90, 100 volts, that means that he is running in a low amperage setting in a high voltage setting. This is what his volt amp curve looks like. He's running low amperage in high voltage. He uses arc length manipulation, and his amperage does not drastically change, and his voltage does not drastically change. In other words, using arc length manipulation, his heat remains relatively consistent compared to running a high amperage and low voltage setting, where using arc length manipulation, tight arc increases amperage, decreases voltage, normal arc decreases amperage, increases voltage. There's more dramatic effect on the amperage and voltage using a high amperage and low voltage setting, such as fourth gear 10, than there is running low amperage range in high voltage setting, such as, say, second gear 70, or second gear 80 or 90 or 100. This is the overlapping of the two. This is low amperage, high voltage, and this is high amperage, low voltage. As you can see here on the low amperage, high voltage chart, a normal arc, which gives arc length, has a voltage of 40 and the amperage of 100. You hold a tight arc, amperage drops off to 30, voltage drops off to 30, and amperage goes up to 125. These are just numbers thrown out here. This is not the real thing. These are just numbers thrown out here just as an example to illustrate a volt amp curve. Now, the welder drops the welder goes up a gear to a higher amperage range and drops voltage. Now, his normal arc will have the same 40 volts and 100 amps. However, the amperage is more significant change, and the voltage has a more significant change when using arc length manipulation. His amperage may go up to 150 amps, and his voltage will drop off to 30. Whereas the low amperage in high voltage range, the amperage may only go up to 125 and the voltage will drop off to 30. This is the overlapping of the two. This one is the low amperage, high voltage, and this one is the high amperage, low voltage. Such as this, and such as this. Now, you're welding vertical up. Say you're welding a heavy wall pipe. You look over at your tag partner, and your tag partner is running low amperage and high voltage. that means that, you know, he's going to have a really soft puddle with the increase in voltage. The voltage is going to make the puddle liquid. It's going to take longer for him to stack metal because the opposing side he just left is going to remain still fairly liquid. A lot of the heat is going to collect up in the middle here. This is what it's going to look like. He's going to move from the left hand side over to the right hand side bevel, over to the left hand side bevel. But what happens is that because he has so much voltage in the puddle, and because the puddle is so soft and the machine lacks the oomph and the drive that push much of the puddle back, he has a very soft puddle. If he takes the tip of his electrode and he touches the pipe, there's a very high chance, because he's running so much voltage, that his arc may extinguish. The welder does not want his arc to extinguish because it's such a piss off whenever your electrode snuffs out. So then the welding operator has to give some arc length. The welder gives arc length so that his electrode does not snuff out and there's a gap between the tip of the electrode and the pipe. Now he's running already a low amperage in high voltage setting. So already there is voltage in his puddle already. However, because he has such a very soft puddle characteristics, you know, because he's running that low amperage and high voltage already, he has to give arc length manipulation. He has to give he pretty much has to take the electrode and pull it away from the pipe. He has to give a gap between the tip of the electrode and the pipe, so he does not touch the pipe and snuff out, because he's running so much voltage. The puddle characteristics are very soft. When he gives arc length manipulation, he increases the voltage even more. So now his puddle is even softer. With the increase in voltage, the puddle takes longer to solidify, adds more heat into the weld zone here, because, you know, the puddle takes longer to solidify. He could be welding over right here. Sorry, his puddle could be over here, and he could be welding over here, and right here is still pretty warm because it hasn't solidified yet. Now he moves from right here and he's giving arc length and he's increasing the voltage. It cuts down the time it takes, it takes longer for him to deposit metal, because with the increase in the arc length, amperage drops down. Amperage and burn-off rate go hand in hand. Since he's giving arc length in the side bevel here, because he has to give arc length, his amperage and his burn-off rate drops and his voltage increases. So it takes longer for him to deposit metal in the side bevel here. He moves from the left hand side over to the right hand side, and he cannot hold a tight arc into the side bevels here. He has to give arc length. So his amperage decreases, his burn-off rate of the electrode decreases, and his voltage increases. With the increase in voltage in the setting that's already volt heavy anyways, this opposing side he just left is still a liquid, or still coming down in temperature. All the heat is collecting in the middle of the weld here. He moves from the left hand side over to the right hand side. He has a volt heavy setting already. He's giving arc length manipulation, holding a normal arc, giving a gap between the tip of the electrode and the pipe so he doesn't touch the pipe and snuff out. He's throwing in more voltage into the puddle. His puddle is more liquid, softer, lacks dig characteristics. The burn-off rate is not there because it lacks the amperage. All in all, he cannot stack metal. He moves from this side to the right hand side, from the right hand side to the left hand side. He cannot stack on top of the metal he deposited on the left hand side because there is so much voltage in the puddle already that he cannot stack on his liquid puddle on top of metal that is still liquid or coming down in temperature that is not a solid foundation. So that slows him down right there because he's running a low amperage in a high voltage setting. You know, and giving arc length manipulation. So you have a drastic increase in voltage. Well, not really drastic, but you have more voltage in the puddle, and you have less amperage. So the burn off rate is not there, the dig characteristics are not there. But what you do have is you have a soft puddle that takes longer to solidify, that is more liquid, a high chance of blowing a hole in the middle of the pipe because that's where all the heat collects, because it's not solidifying over here, and the heat kind of sort of follows you to the right hand side, but it still hasn't solidified yet fully on the left hand side, so all the heat is going to collect in the middle here. You move from the right hand side over to the left hand side. This left hand side hasn't solidified. The heat, it's kind of sort of following you, but it's, you know, the puddle hasn't solidified fully yet. You move from right hand side back over to the left hand side. It's just tossing more heat into the middle here. You're going to blow a hole in the middle there because you have so much voltage in the puddle. Plus, since you're giving arc length manipulation, if you do happen to touch the pipe all of a sudden, your electrode is going to snuff out. If it does not snuff out for good, then what will happen is that the electrode will suddenly snuff out, and then it will reignite. Every single time it reignites, you basically have a bare tip on the end of your electrode there. That's the same as just, if you want to strike an arc, that's the same as just touching and then just start welding. If you're doing a weld from, oh, my pen doesn't work. If you're doing a weld from A, B, if you're welding from A to B with a 78 electrode, you have to scratch start right here and then come down to A and then start welding, because you'll leave surface porosity right here. However, when you snuff out the electrode down here, the electrode suddenly reignites and you keep welding, you just put porosity right there. That's the very same as saying, I want to weld from A to B, I'm just going to touch the electrode right here, and I'm just going to start welding. You're going to get surface porosity right there. And that's why you have porosity, especially on the film. That's also why you burn through, because you have too much voltage. The opposing side you just left hasn't solidified yet. That's also why you're slow, because you cannot stack metal, a liquid puddle, on top of a metal that has not solidified yet. Now suddenly we have a welder who actually knows how to weld. He knows how to set his machine. He is a good welder, he's a fast welder. Does not get silly little weld faults. He's fast, he's able to stack metal. How does he do it? He goes up to high amperage, low voltage. Say 4th gear 1020, 5th gear 1020, burning a 1/8 electrode, 532 electrode, vertical up position weld. You also have the help of the volt-amp curve. You see, using arc length manipulation, his amperage and his voltage changes dramatically. You look at that welder's remote. In his remote is, say, 40, 30, 20, 10 volts. You would hope to have 30 and 20 and 10. The lesser the voltage and the higher the amperage, the better. If you want to stack, say, welding 7018 electrode. But you see, 6010 does not like low voltage. And it'll tell you right in the 300D manual that you'll have arc instability if you have low voltage. Now this welder, he knows how to set his machine, he knows how to weld. He's running the high amperage, as high as amperage as he possibly can get, and he's running as low voltage as he possibly can get. See, 5th gear and 10 volts is too much for a 1/8 electrode. So he has to drop down to 4th gear and say 10, 15, 20 volts, which is perfect for the 1/8 electrode. Now that welder, he pauses on the left hand side. He takes the electrode and he snuffs it into the left hand side bevel. Even his welder's helper is pushing on the electrode, and he's trying to push the tip of the electrode into the pipe. opening a crater and he just keeps pouring and pouring metal in. You're not going to snuff out holding a tight arc on a high amperage, low voltage setting. So you can get away with holding a very, very tight arc and pushing into the side bevel there, because you're not going to snuff out ever. With the tight arc, amperage increases, burn-off rate increases, voltage drops off, so he's able to pour a lot of metal in a very short amount of time. He's able to dump metal into the side bevel here, and because the voltage decreases, the puddle solidifies. He moves from the left-hand side. He's content and happy with the amount of fill he deposited into left-hand side bevel, and this is pretty much how much metal he's going to deposit holding a tight arc. He's going to deposit a ton of metal in there. He moves from the left-hand side over to the right-hand side. He holds a tight arc into the side bevel there. The very second he holds a tight arc, amperage increases, burn-off rate increases, voltage drops off, lack of voltage chills out the puddle. The left-hand side here starts to solidify. He's over at the right-hand side. The left-hand side has solidified. He's content with the amount of fill that he just deposited on the right-hand side, and he deposits a lot of metal on the right-hand side. He wants to stack metal. He moves from the right-hand side, he takes his liquid puddle, he moves to the right-hand side, and he carries all the way over to the left-hand side. He's able to stack his liquid puddle on top of metal that has just solidified. And it has just solidified because it lacks voltage in the puddle. So he's able to stack his liquid puddle on top of metal that just solidified. He's not going to get porosity because he holds a tight arc. He doesn't have to worry about the electrodes snuffing out. He'll burn out wagon tracks. If he's doing downhand, he'll burn out the wagon track because he has the dig characteristics on the high amperage, low voltage setting. He's able to stack metal because the metal is always solidifying behind him because it lacks voltage, especially when he uses arc length manipulation, which a tight arc increases amperage and drops voltage even more. And with the reduction in voltage, the puddle solidifies. So he's able to stack liquid puddle on top of solidified metal. I covered porosity. I covered burn through. You see, you're not going to blow a big hole in the middle here because it solidifies from the left hand side. It starts to solidify when you go to the right hand side. It starts to solidify when you go back to the left hand side. The heat is not going to collect. Your puddle is not going to remain liquid, and you're not going to blow a big hole in the middle of the pipe here because your puddle solidifies as it follows you. It's not liquid back here while you are over here. It is solidified and it's on its way to follow you. That's running the high amperage and low voltage setting. However, if you want to burn through, then you put it to low amperage and high voltage setting, and when you move from here to over here, your puddle is still going to be liquid, and you move from right over here and trying to stack metal on top of this metal that hasn't solidified yet. You move from here over here. The heat's going to just travel like this, and it's going to move over here, and all the heat's going to collect up in the middle here. You're going to blow a big hole. And it's because you don't know how to set your machine. You're running low voltage, the high volt, or you're running the low amperage and high voltage setting. A lot of voltage in the puddle. Puddle remains relatively liquid, takes longer to solidify. Say if you're doing a vertical up, certain machines like a Miller XMT 304, 350, too much voltage, putting it to say a soft arc, which increases voltage. Your metal is going to come out like a glob in the middle of the pipe there, and it doesn't matter how long you solidify on the sides there, your metal is still going to remain a blob of metal in the middle there. It's going to remain liquid. It's not going to solidify. It's not going to follow you. You're not going to make nice flat beads. You're not going to make nice flat beads. Your weld is going to be globs of metal in the middle of the pipe there. Where this is just a huge glob of metal in the middle of the pipe there, and these are your sides, and you end up undercutting the sides. So if you want to be a good welder, where they hang your welding helmet from the rafters there, and you shut out the lights. They're going to run the high amperage and low voltage setting. If you're doing, say, like a fill pass with, say, like 7018, certain electrodes don't mind the low voltage. 6010 does not like low voltage. If the voltage gets too low, you'll have arc instability. So this is what you need to know. These are the 2 volt amp curves. High amperage, low voltage, low amperage, high voltage. You see the volt amp curve. You see the change in the amperage and the voltage. This is a drooping volt amp curve. But you see the change in the amperage and the voltage using arc length manipulation. You know, also able to hold a tight arc. You see, if you're more volt heavy, then you have to give arc length so you don't snuff out the electrode. So that increases the voltage even more and drops the amperage even more. You know, you lack the burn off rate because you're volt heavy already, and you're adding arc length manipulation, which increases voltage. Whereas if you're smart, you know how to set your machine, you know how to weld, you know, you're not going to get silly little weld faults. You know, you're not going to get porosity, you're not going to blow a hole in the middle in the weld there, and not going to lose control of your puddle or nothing. You know, your puddle's going to solidify quicker. It's not going to be as liquid. You know, you're not going to heat up a huge area because the metal hasn't solidified yet. You know. But like I was saying before, you know, inverter, generator. You change the amperage on the inverter, the voltage, which is the arc control. Soft setting is high voltage, crisp setting is low voltage. You see, you change the amperage on an inverter. The voltage, you're not able to change the voltage on an inverter using a remote. I believe they do have certain special remotes made that you can change the arc characteristics, which is your soft setting, crisp setting is what it says in a lot of machines. You know, sometimes it's like -10 and +10, wherever it is. Your arc control is your voltage. But on an inverter, you'll be changing the amperage. On a generator, you're changing the voltage. Your puddle characteristics change, and your volt amp curve changes. The effects of arc length manipulation changes depending on your voltage, because you're changing your voltage on your machine here, but also at the same time, because you're in an amperage range, your amperage also goes up. Something to do with the electrical and a pathway that with the pathway of voltage, the amperage will have a pathway to go wherever the hell it is. But yeah,